Definitely. Let's go.
All right. I'm going to just hide that right there. All right. Well, we have a great presentation for you guys tonight. We are going to talk about protocol creation and customization, as well as raw data export for analysis and third-party tools. Anna-Rosa from our European office is staying up late for us tonight. She's also going to introduce a brand new bulk exporting tool that we've just released. This presentation is going to cover a lot of material, so please keep your mics off to prevent interruptions that may slow things down. If you have a question during the presentation, please type it into the chat box in the GoToMeeting sidebar. We're going to be monitoring that during the presentation, and we're also going to be addressing those questions in the Q&A session at the end. So please give us your questions if you need, or if you have any questions during the presentation, please let us know. Since there's going to be a lot of material on these slides, we're probably not going to be able to cover all of it. I'm also going to be making a PDF of this presentation available immediately at the end of the slideshow for everybody to download as a reference. We will be recording this webinar, so we'll be distributing a link to this recording for anyone who wants it later as well. For those of you who don't know me, my name is Natalie Doran. I'm the Director of Customer Support of the US office at Diagnosys. I'm joined tonight by our CEO, Jeff Farmer, and by Anna-Rosa Gejlsbjerg, the Head of Sales and Support in our European and UK offices. I think I just saw also joining us tonight is Rich Camara, who heads our international business development. So I'm going to try, we've got a lot to cover tonight. I'm going to try and skip through as much of the intro as I can. You guys know us, we've been around for a long time. We are the leader in ophthalmic electrophysiology, both in human and in animal testing applications. Our animal testing platforms have been used on everything from zebrafish larvae to horses and everything in between. And I'm pretty sure we were actually, the color dome was used to test elephants too, prior to cataract surgery, but I can't prove that was us, so I can't really claim it, but I'm pretty sure. The Celeris is at the forefront of small animal ERGs. The rapid setup of the Celeris allows for fast, easy, highly reproducible recordings, even by new users. The strength of the Celeris comes from the silver-silver chloride electrodes that are combined with the LED stimulator, each of which we can control independently. We have both pattern and full field stimulators available in a variety of sizes that fit everything from baby mice to adult rats to rabbits. The dicoptic nature of the Celeris stimulator allows for what we call touch-touch protocols. Touch-touch protocols are so named because you touch one stimulator to one eye, you touch another one to the other eye, and then you're done with setup. Touch-touch protocols do not require an additional external reference or ground electrode. The touch-touch protocols interleave flashes between two eyes. What they do is they stimulate one eye and use the fellow eye as the reference, and then they invert that setup. So this video here shows a mouse being stimulated with a flicker ERG. You can see it started with the right eye, and then it moves on to the left eye as soon as the right eye is finished. Protocols that stimulate both eyes at the same time and use sort of the standard needle reference electrode in the forehead, those work completely fine on the Celeris as well. You'll hear me refer to those in the during the presentation as active reference ground protocols. So we can do those as well. The thing is that having the ability to do the touch-touch really gives you the opportunity for a much better response. Having the twin chlorided electrodes dramatically reduces noise and variability. So in this case, so this test was a head-to-head comparison of the touch-touch configuration in the right eye and an active reference ground configuration on the left eye. So the right eye was set up for touch-touch, so the active was the right eye, and it was using left eye as a reference. And the left eye had a needle in the forehead as a reference. And the thing is that if you have a needle electrode, the impedance difference between the needle and between each of the corneal electrodes creates more noise, and it creates a lot more variability, as you can see. This was done at the same intensity. I think this is either 10 or 20 candelliseconds per meter squared. I don't remember exactly. But you can see that the touch confers a huge amount of reproducibility in the trace. The Celeris can be used on a variety of animals, from baby mice, there's a 21-day-old mouse here, to guinea pigs, to chickens, rats, rabbits. I think somebody was using tree shrews. So you can really, any small animal really, you can run on the Celeris. It has very high repeatability. The largest ERG signal, all things considered, is going to come from dead center in the middle of the cornea. What that means is that since the ring electrode that encircles the light guide stimulus is approximately the same as the mouse eye, even if you position it slightly differently each time, the average difference of each point on that ring is always going to be the same distance from the center of the cornea. And what that means is you've really eliminated a lot of the variability due to placement of the electrode. So I have two test series here that show that. On the left, what we did was we took the electrode, put it on the eye, took a result, took it off, and then placed it in a slightly different position, and then took it off, and then placed it in a slightly different position. And you can see that all three of the responses were exactly the same. We did this again separately, independently. We did this at another lab where they actually had somebody who'd never done ERGs before come in, put the electrodes on the animal, run a result, take them off, put them on again, run a result. They did that 5 times, and you can see that each time they got basically the same result. So really there's very low variability due to the electrode placement, and allows for much faster setup. So here are some example responses from our full field stimulators. We also have pattern stimulators that can do pattern ERGs, pattern VEPs. We're also working right now to optimize a multifocal ERG protocol for the Celeris as well. It's not quite ready for prime time, but we're working on it. So we have like a nearly limitless range of options for designing or optimizing protocols. Our flash stimulus spans 9 orders of magnitude. The background illumination can be set within 1%. We have tremendous options in terms of acquisition parameters, sample frequency, filter pairs, and reporting as well. So we really do have very powerful software. This is an important slide. I really want to pause here for a second. This is the current slate of protocols that we have for the Celeris right now. We're constantly updating these and releasing new ones. So if you see something you'd like but you don't have, or if you'd like to know, if you've got your Celeris 6 months ago, a year ago, 2 years ago, if you'd like to know if you have the latest version of these protocols, get in touch, let us know. In terms of updating or customizing protocols, it's very easy to do either in runtime or more permanently. In runtime, you can easily add steps to an existing protocol to add additional luminances, for example. In the test that I showed earlier, where we were looking at the difference between the touch and the active reference ground protocols, what we actually did was we set that animal up, and then during testing, they wanted to keep on adding brighter and brighter intensities to see if the changes in variability held true as the luminance increased, which they did. So it only took about 20 seconds per step to add a new step and increase the luminance every single time. So it's very easy to make changes on the fly. We don't actually recommend building new protocols from scratch. I don't recommend you use that new button down there. There are a lot of different moving parts to a protocol. There are stimulus parameters, there are recording parameters, there are filter settings, there are marker settings, there's default print layouts, default export layouts. So there's a lot of things that you might overlook if you're just trying to build one from scratch. So what we recommend doing is taking a protocol that does approximately what you'd like it to do, and to make a copy of that and to use it as a template to customize it to be exactly what you need. This process, and I really want to specify this, we're going to get deep down into the weeds about all of the different possibilities you can take advantage of when building these protocols or customizing these protocols. But this process generally only takes a couple of minutes. This presentation is going to go into a lot of detail, but typically when you're modifying protocols, you're just adding or deleting steps. You're changing a couple of luminances. You're increasing interstimulus intervals, and that's it. It's generally just going to be a couple of minutes of your time. So once you do take a template protocol and make a copy of it, you're going to be dumped into the protocol details page, which is where you can change the name and the comments of the protocols. You can also always go back. You can reach this page by pressing the modify button after selecting a protocol on the protocols details page. And I highly recommend taking advantage of this hide protocol option and hiding old versions of protocols you're not going to use anymore. That's going to make the protocol selection page much more streamlined, and it's going to reduce the chance of someone accidentally running tests under a recently obsoleted protocol. The protocol details page also lets you set the number of channels. So channels are the recorded inputs coming off of an amplifier. The Celeris only has 2 amplifier inputs. It's only got 2 input channels. And the other systems that we sell only have 5. But the use of virtual channels, which are digital copies of input channels, and the use of the touch-touch paradigm allow you to have a maximum of 16 channels in a protocol. For example, over here, what we have is an ERG response where I think this is just a bright light adapted ERG. And then the middle 2 graphs are the oscillatory potentials. So those little wavelets on the ascending face of the B wave. So these are digital copies of the ERG channels that are filtered much more tightly, so you can just exclusively see those oscillatory potentials. And then down at the bottom, we have a digital copy of those ERG channels again, but this time it's filtered more aggressively again, so that we can remove those OPs and so that we can get a little bit easier and clearer placement of the B wave. Similarly, we've got something over here. This is a combined flash ERG and flash VEP protocol, where at the top we have the ERG response. In the middle, we have the oscillatory potential response. And down at the bottom, we had the channel 2, the actual input channels, channel 2 of the flash VEP for the right eye and the left eye. So both of these protocols, despite there only being 2 amplifier inputs, had 6 channels that were being used. So it's another way for you to take more data and look more closely in the data. In the protocol parameters itself, there are global parameters, which affect the entire protocol, and there are individual step parameters, which affect only the currently selected step, and you can see which step you have collected at the top left here. Some parameters, like channels or markers, only affect the currently selected channel or the currently selected marker, and you can select that in the bottom left of that window. Global parameters, here are some examples here. These are mostly things like the screen display options, the print and export options, and whether the test forces you to check impedances or automatically advances through the protocol as you're running a test. So again, the global parameters are parameters that don't affect individual steps individually, but just the entire protocol as a whole. Once we get into the individual step parameters, again, these are only affecting the step that's selected at the top left. General parameters are all the individual step parameters that don't specifically address recording, stimulus, or marker parameters. So these are things like the name of the step, the number of responses recorded, and some of the touch protocols. Later on in this presentation, I'm going to talk more specifically about what makes a touch protocol versus an active reference ground protocol, and what the important parameters you'll want to toggle are going to be. General parameters are also where you can leave notes or instructions for yourself on a given step. For our protocols, what we like to do is have the first step have a little message text when you first load it that tells you how to set up the animal. Acquisition parameters, the second tab in, these relate to the recording of the response. So these are going to be options like the number of data points taken per second, which is the sample frequency, how long to record either before the flash or after the flash, and how long to wait in between stimuli. There's also the first sweep delay. We strongly recommend that the first sweep delay of at least the first step be 6 seconds, because it takes about that long for the amplifiers to settle after initializing the filters. If you're going to keep the filter settings the same among all of the steps, which most people do, then it's only the first step that needs to have that 6 second first sweep delay. But we really strongly recommend that at least the first step have a 6 second first sweep delay. Stimulus parameters, these are the stimulus parameters for the full field. In addition to flashes, flickers, or long pulses of light, you can also do ramp stimuli, like ramp up or ramp down, to specifically target on or off bipolar cell responses. You can also do sine wave stimuli, square wave stimuli, exponential up or exponential down responses. You can even do, if you want to learn more about programming user-defined files, let us know. We'd be happy to send you some information about how you can get started doing that. User-defined files might be something like a double flash or multiple sine waves going simultaneously, where you're doing blue at 1 hertz and red at 2 hertz and green at 3 hertz for some reason, if you want to have like a little disco party. Our stimulators have red, green, and blue LEDs in them, or standard stimulators do. Ultraviolet stimulators will replace one of those colors, usually blue, with ultraviolet. That means that our white 6500K is a metameric combination of red, green, and blue that is mixed to make a daylight white. We have, so these are the colors that come available with the system. So that's white, red, green, and blue, obviously, are all the standard colors. Peak is red, green, and blue again, but instead of following a recipe where we modulate the different intensities in order to make white, we just drive them all at the same intensity. So you can get a brighter flash out of peak than you can out of white generally, but it'll start to look kind of purplish at the higher intensities. Rod, similarly, is green and blue, both driven at the same intensity. Rod is actually a really great color for stimulating rodents because it's better than white for stimulating rodents, because white is red, green, and blue with quite a lot of power actually in coming from the red, which they can't see very well, whereas rod is entirely green and blue. So all things considered, a flash of 3 in white is going to look dimmer to a rat or a mouse than a flash of 3 in rod. So you might consider using rod in your protocols instead of white. We typically provide white as our standard because that's what everybody else does, because that's what everybody else can do. But rod might give you better responses. So something to consider. These are the protocol parameters for our pattern protocols. Pattern stimuli can appear as a checkerboard, as bars, as horizontal lines, or as gratings, which are sinusoidal bars. You can set the contrast anywhere between 0 and 100%. And the timing can be set to either onset, offset, where you can set how long it's one way and how long it's the other, or pattern reversal, where you can set the number of reversals per second. For reversal stimuli, you can choose to optionally trigger on both edges of the stimulus or just one. So if you think about a checkerboard going black to white, black to white, black to white, triggering on just triggering on both edges would be to trigger when it goes from black to white and also when it goes white to black. Whereas triggering just on the first edge would be black to white, black to white, black to white. In order for the size of the stimulus to be correct, the distance should be set to 340 millimeters. That's up here. Prior versions of our pattern protocols had this set to 1100 millimeters. This doesn't mean that your old protocols are wrong or don't work. It just means that they aren't as optimized as the current protocols. So if you have been using the old ones all along, that's totally fine. Contact us when you're between studies and we can send you the latest version to switch over when you're free. Since the pinhole aperture can be kind of difficult to see through and the viewport on top kind of difficult to visualize the pattern stimulus through, if you're working on complicated pattern stimuli, we do have an optional pattern viewer which pairs a human optic with a Celeris pattern stimulator port. And you can contact us to if you'd like to learn more. They're significantly less expensive than the pattern stimulators themselves. If you're interested in doing complicated custom stimuli in particular, that they're really useful for making sure that you're getting what you think you are. Next up, we have channels. So channel parameters are recording parameters. Channel parameters only affect the selected channel of the selected step. So filters affect the frequencies that are present in the response. Our filters are all digital, which means that you can specify any filter pair that you like. I put some common filter pairs in this slide. Filters for ERG responses are typically less than 1 to about 300. Filter for OPs are typically 75 to 300 or 100 to 300. And filters for VEPs are generally from 1 to 100. I've shown this test on prior slides to demonstrate how you can use virtual channels. The graphs at the bottom that were intended to remove OPs to better show the B wave amplitudes, these were filtered at about 0.3 to 30 hertz. So this shows you basically how filters work in channels. Also in the channels tab are some more important touch parameters. Again, we're going to touch more on we'll talk more about touch versus active reference ground later in this presentation. Also important here, I've touched on which is the amplifier input 1 and which is amplifier input 2 in the Celeris. So this tells you for a given channel which amplifier input it's going to be using. This parameter is completely ignored if you're using a virtual channel. Virtual channels, like I mentioned before, are digital copies of existing channels. So this allows you to refilter channels in multiple ways, or for example, to subtract one channel from another. So the top two channels here are real channels from a touch protocol, where both channel 1 and channel 2 used amplifier input 1. These two channels were digital channels that were virtual to channels 1 and 2 here. And channels 5 and 6 are also virtual to these two and use a different, totally different set of type filters. You can also use, as you can see, virtual channels to subtract one channel from another. So you could get this another way rather than using tight filters. You could simply say that I want this channel to be this one minus this one. Finally, we have markers. Like channels, the markers parameters only apply to the selected marker of the selected step. So there are three main parts to defining markers. First, you talk about the display values, which is what you want to measure, like timing or like amplitude. Then the placement algorithm, which is where the marker is going to go, and then onto what channels they'll be applied. So in terms of display values, this is where you determine if you're interested in looking at timing or at amplitude. If the marker is relative, like a B wave marker, or like the peak in a flicker that's measured from the preceding trough, you would say that the amplitude is relative to that there. And you're also not limited just to timing or amplitude with markers. You can also use them to measure, for example, the RMS of a portion of the trace, or slope, ratio, the sum of a number of peaks. So you can actually do quite a lot with just the reporting within our software. And then finally, in terms of placement, the placement algorithm is pretty basic. The way this one is set up right now, it would look for the most negative point starting at 9 milliseconds and running until 40 milliseconds. So what it would do is it would find the lowest point between 9 and 40 milliseconds and put I guess this would be the A wave marker there. All right, so I promised you this slide. What makes a protocol touch-touch versus active reference ground? For starters, you need to tell it whether to alternate eyes between sweeps or alternate eyes between results. You'd use alternate eyes between sweeps if you're looking at single flash responses where it's going 1, 1, 1, 1. You would use alternate eyes between results for flickers. For a steady state protocol, or for a steady state stimulus rather, you need to complete the stimulus on one eye before you start it on the other, because you can't use the fellow eye as a reference. It's also experiencing the same stimulus. The intersweep delay should be twice as long for an active reference ground response or active reference ground protocol as it should be for a touch-touch. The reason for that is in active reference ground protocols, there's a flash on both eyes, and then there's the interval, and then there's the flash on both eyes again. In touch-touch protocols, the right eye flashes, and then there's an interval, and then the left eye flashes, and then there's an interval, and then the right eye flashes again. So each eye is actually waiting for 2 intervals in between each stimulus. So that means that you want the touch-touch value to be 1/2 of what it would be if you were stimulating the eyes binocularly. In the stimulus parameters, there's a lock button for at the top of the page for flash stimuli. You want to turn on the lock button. That means use both of them and use them both at the same time. And then finally, the channels parameters. These refer to the left eye only. For active reference ground protocols, you would have the left eye get its own channel, and that channel would be channel 2. For touch-touch protocols, it would also be fed into channel 1, so it would be acting as the reference for the right eye. And then you would also want to turn on invert polarity for the left eye for touch-touch protocols, because since it's acting for the reference, if you don't invert it, everything's going to be upside down. If you have a minor change that you want to make across the entire protocol, the copy node tool is great for that kind of thing. So, for example, if you wanted to change the number of sweeps per result in a step or in a whole protocol from 3 to 10, what you would do is you would make the change on one step, and then with that parameter still selected, you would press the copy node button here. And what it would do then is it would say, do you want to copy this node and any subnodes from the current step to all other steps? If you then say yes, then all of these other steps are going to go from having 3 sweeps per result to 10. So if you've already built this really huge long protocol, you can see this one's 34 steps long, and then you realize, oh no, I forgot to make this change. you can then really quickly make changes, small changes, with this copy node button. If you're doing this in channels or markers, it will ask you a similar question. It will say, do you want to copy this node to all other channels of this step or the same channel of all other steps? So for example, if you were changing the low cut of the OPs from, or the low bandpass filter of the OPs from 75 hertz to 100 hertz, then what you would do is you would change on channel 3 of the first step. You'd change the low cut from 75 to 100, and then you'd press this copy node button. And if you answered this question with steps, then channel 3's low cut would be 100 for all of these 34 steps. It would be updated from 75. So you've just saved yourself 64 mouse clicks. So copy node is extremely powerful there. The copy step button will overwrite every step with the step you currently have selected. So handle that one with care. I don't like that button. I pressed it a couple times by accident without paying attention. There is a stop check. And then the new step button will create a new step exactly like the one you've got, and ask if you want to insert it immediately after the step you have selected or at the very end of the protocol. And the delete step button will delete the step you have selected. And then the last one I have before I turn this over to Anna-Rosa, the drift removal and baseline subtract are both recording parameters that can remove baseline drift. Drift removal, also called trend removal, is dynamic and will sort of bend the trace to remove a perceived baseline drift based on responses recorded at the beginning and at the end of the trace. Baseline subtract, also known as DC removal or offset removal, is a constant within a trace. It'll subtract the same value from every point on the trace, and it's basically used to make sure that zero is at zero. Neither of those will work for steady state stimuli like a flicker. They both require that the eye sort of start in a ready state and end in a ready state. So it's not going to work if you record for very short periods of time, or if you've got a steady state stimulus where you've got a response that will be coming before T0. And that is the end of the slides that I have. So I'm going to turn this over to Anna-Rosa.
Thank you very much, Natalie. So I'm going to talk about something that most of you are doing every day, a lot in your research, which is exporting data to third-party applications from the SPN software. So this is something that is an additional to using the SPN software and the Celeris software. We are getting the data out to analyze them in different ways. There we go. So first I will talk about the built-in software that we have in the SPN itself and how we can export data from within the SPN and the Celeris. So this is what you're already familiar with. This has been around for many years, and that's what we can do when we use the software. So with in this SPN software, it's 4 steps, 4 easy steps to export data. We select the test, we load the test, then we press export, and then we select the options we want. We can set some of these options up in the default for our protocol, so we don't have to set them every time. And then we export the data in the required format. Here's an example on how to export the data. There are 2 examples here. The first one, we select our mouse, and we press the old test button, and then we get a list of the old test for that mouse, and we press load for the test we want to prepare to export. The second example, we have a long list of mice, and we select the mouse, go to the protocol page, and from the protocol, we can load the old test as well. So there's two ways to get to the place where we can actually export the data. So when we got into our normal analysis window after we have loaded our tests, there are two ways then we can go from there to export our tests. The first way is that we can, the test be loaded, we can go straight ahead and export that. So we do that by pressing the export button, checking that all the defaults that are set up for that protocol for the export are correct, and then we can export from there. The other thing we can do is we can manually load and combine tests. So we can press, instead of the export button, we can, with our test, we press the load button, and that will give us a list of other tests, either for that patient or animal or for that protocol. We can do various combinations. It will allow us to load them in together into one file. So it will all be presented in the window as one file, and then we can export that one file. It will give one sheet in your Excel, for example, if you do it that. It won't separate it out in individual sheets for each animal. It will be one file. But it's a way we can export multiple animals. The problem when you export a lot of animals this way is that you are limited by the amount of power that your computer has, because it has to load all the tests into the memory on the computer. So there's a limit to how it's done. It can be done. It doesn't like to move here, my slides. There we go. Oh, that's one too many. Okay, so in the export menu, which is what we get up when we press the export button, there are many things we can set up, and we can set them up in the default in the protocol. So the first thing is that there's something called a contents table. We can turn that on if we are using automatic macros in our Excel to handle the data as it comes in. That will allow our macro to know exactly where all the data is going to be stored in the rest of the file that we are using from this. We get information, we can get information about the protocol, the marker values, all the step parameters. We can get the average data, and we can get the individual suite data in ASCII format, or we can get it out as a meta file, a graphic format, either to a file, to the clipboard, or we can drag and drop it into third-party applications. We can separate the data in the file by selecting from the separator tab, and gives us the ability to tailor it for the application we want the data to be imported into. When we have to set up all our required parameters that we want in the file, we select whether we want to export it to clipboard, graphics, or file. When we've selected that option, we just press export, and that creates our export file in CSV file format or in graphics or drag and drop. So here's an example of how you can export to a file. So I have ticked the file button, and I pressed export. I created a file called my exporters example, and I have taken that file and I have loaded it into my Excel spreadsheet at the top with the green lines. So that is, for example, you can see here an example of the content table that would tell my macro where everything else is in my data in this file. In the second example here, I have copied to clipboard. I have selected clipboard, pressed export, and I have dumped the data straight into my Excel spreadsheet. And then I have selected a row of data points from my spreadsheet, and I have created very quickly the curve, which is the same as you would have seen in the SPN software. So you can reanalyze your data into your other application, MATLAB, SigmaPlot, Excel. If you want to export to graphics, it's also very easy. You press the graphics button and you get a slightly different menu that has some, allows you to either export all steps or just the step that you are on. You can export graphs, market tables, and you do that by clicking on the bottom and dragging it over to your application. So for example, your Word document, you just drag that little icon over into your PowerPoint, and that will take the graph as it looks on the screen straight into that application. It is what you see is what you get. So if you have arranged it all nicely on your screen, you get that like that in your application that you can use for your PowerPoint presentation, for your Monday morning meeting when you're discussing your results with the rest of the group. You can also take the data out as a meta file, and you can load that meta file into our application and do further manipulation with it. So you just can take it straight in there and open the file there and do further manipulation. So one of the things about the standard way of exporting data is it works fine if you have not very much data. But we had lots of you work with many tests, and you need to constantly export that data. So we had a request for an easier way to do bulk export of data from the SPN software. So we have just launched a new SPN exporter software that allows it to be more easily available for you to export lots and lots of data to your third-party applications. So the problem is you have many subjects, animals that have all been tested on the same protocol, and lots of data you want to export. And as you could see, you can go through the SPN software, but you have to go through it, load every test, combine them, then export them, then have to work out which test belongs to which animal. And you want to have an easier way to do that. If you're doing 1,000 animals or 100 animals, you want to go take over and do further analysis on. So with the exporter tool, you can take one EXP file, that's a transfer file from the SPN program with multiple tests, and then you can, that exporter software will automatically generate one text file per test without having to use the SPN software. This also allows you to send your data to someone else who hasn't got the SPN software, and they can use this software to extract all the data and do further analysis on it. We have a free time unlimited trial versions available of this software for anyone who wants to use it. Just contact Diagnosys support. I'm very happy to give you a link to download this file so you can have a go at it and see if that will solve some of your bulk export problems and make your life easier. There's a slight difference between the trial version and the full licensed version. With the trial version, you can load one file in with one or more tests, but you can only load one file each time you run the software. You can only export one test each time you run the software, and you can only export to the directory where the software lives. And you have limited ability to view the data in the export itself. If you have the full version, you can load all the tests you like or selections of tests. You can define where it should be exported to. There's no restrictions, and you can get a full record data view in the exporter as well if you want to. So when you have tried it out and if you like it, contact us. We have both single licenses and multiple PC licenses available from Diagnosys. So how do we go about creating the EXP file in the SPN software? We do that with the transfer function. We need to create an EXP file. So we do that by selecting group of tests to include in the export file, for example, all tests for protocol, all tests for certain dates. And we can filter on dates, a certain date or between certain dates, several dates. And we do that with the filter and sort functions in the SBN software. And you can find more information in the SBN user guide for that. So here's an example of how to create a transfer file. We select the subject, then we select the protocol, we press the old test, and we want all the tests for this particular protocol. So we untick the patient flag, and that will give us all 3 tests in this case. And then we press transfer, and that will generate an EXP file we then can use in the exporter software. We then take our exporter software, we open this file, and here we got the file, example file, and we can see a subset, or we can see the full range of the tests, or we can use the record view if we want to see the actual data in each of these in this tree structure. We press export, and then that generates 1 text file per test for either current directory or where we have specified it. And then we can automate that fully into our third-party software and import them and handle them further. So we can really automate everything with this software. And to help you do that, you can name the files so they're easy for your third-party application to input the data. So you have all the ability to use the combination of fields to name the file for the export and the automatic handling of the data. And finally, here's an example of a file that has been created. On the left-hand side, I've got a list of files, and they've been created and put straight into my Excel, and then I can do further analysis on it. This is a software that we're very happy to hear if anyone has suggestions for new features. If you have the full license, you get free software updates, and we are working on putting new features into it all the time as people request them. And that's it for the exporter software.
Excellent. Thank you, Anna-Rosa and Natalie. So you guys covered a tremendous amount of ground. We have about 13 minutes yet. We can handle questions. We don't actually have any questions in the chat bar right now. So if folks have questions, go ahead and type them in. I've got 1 or 2 that I'll use to get us started. One, let's start off with this. Your opinion, both of you, Anna-Rosa maybe first, and then Natalie. I think combined, you guys have probably close to 30 years of experience working with electrophysiology customers, and you're obviously really familiar with our software, and I think also with the software of other companies that are our peers in the market. Here's my question. How would you compare the capabilities we have for protocol creation and exporting to other companies' software, just at a high level? What do you think are some of the advantages we have?
Natalie, do you want to?
I forgot I muted myself. Yeah, so I don't have a ton of experience with other manufacturers in exporting their raw data, so I wouldn't want to speak to that. I will say that creating protocols with our equipment, or at least updating them, modifying them, is significantly easier and significantly faster with our equipment than some of our closest competitors are. So I see some questions are starting to roll into the chat. What electrode do we use to record the VEP? The responses that I showed earlier, that was just a needle electrode subdermally across the midline in the back of the head. I know you can get better responses if you use an alligator clip on a skull post, and that's fine. But for that was taken at a customer site, and what they were looking for was sort of a quick and dirty VEP to sort of get a full picture of the visual pathway of those animals. So they were just using a needle electrode in the back of the head, and then a reference needle in the snout. Hi, What? How you doing?
So in regards to export of your data, one of the things that when I talk to people, they're very much aware that with our software, just like with the protocol, we give a lot of very powerful tools to people to generate protocols. We also allow everyone to get to all the data. We don't hide any data. We allow you to export the data, take the data out to something else. So it's there are tools for you there to take them out, and that not everyone has an ability to actually access all the raw data, take them further, to do further analysis.
Excellent. Thank you, Anna-Rosa. I'll take the next one, Natalie, and then there's one after that. So the next question is, will the multifocal ERG protocol use a different electrode? The answer is no. The active electrode for the multifocal ERG will be the electrode that's integrated into the pattern stimulator that Natalie showed in one of her first slides. And we're setting this up as a touch-touch protocol. So the reference will be the electrode on the fellow eye with a full field stimulator, for example. And then Natalie, we have a question about OPs. Do you see that one?
Okay. Can we get OP data after ERGs are recorded, and how? So not in our software currently now. We do not currently offer post hoc filtration in the ERG BEP modules. That's something that we've wanted to do for a long time, but would require a substantial rewrite of a lot of the infrastructure of our software. So that's something where you would either need to modify your protocol to add OP channels to collect them going forward. And looking back on historical data that you've already collected, there are macros you can use in Excel or MATLAB that can help you run, for example, like Fourier transforms. That can help extract that information from existing data. But unfortunately, our software is currently not able to do that.
Yeah, and on the MATLAB point or similar programs, it's a very simple thing to do, to export and then just filter to a high frequency.
Yeah.
As Natalie mentioned, for mice, it may be 70 hertz and above, but quick thing to do in MATLAB. Let's see. No other questions? Let's see if more come in. Natalie, another topic that maybe we could spend a minute on, can you just talk about our UV stimulators and how those are programmed in our software?
Sure. So let me just slide back to our stimulus parameters here. So the stimulus parameters here, flashes are measured in candelaseconds per meter squared. That is a visual unit. It's based on the human spectral curve and what we can detect. And that's not relevant or useful for for ultraviolet, which we can't see. So for ultraviolet, we use microwatts per centimeter square. And the numbers here are exactly going to be the same. The units are going to say candelaseconds, but if you're using the color that we've swapped out UV stimulators for UV, then that unit would actually be microwatts. So we've set it up so it's a one-to-one sort of correspondence.
Very good. Next question is, how can I update my Espeon software?
So Espeon software updates are free throughout the life of the product. The best way to get an update is to send an email to support@diagnosysllc.com and just say, I would like to update my software. We can provide you for a link to the download. It's generally just as easy as a link to a download and just running a self-extractable patch file. We like to be involved just in case you have a really old version of the software. Taking you from an old version to a more recent version can sometimes take some intermediate steps. So we like to be involved just to make sure that if you are one of those people who needs to take some extra steps, that we're there to help you with it and we know about it. So just shoot us an email. The email address again is support@diagnosysllc.com, and any of us can help you. Oops. Any of us can help you, and I accidentally closed. I went too fast.
There you go. Next question. So the next question is for the pattern ERG, how can we make sure, or how do we make sure the pattern is well focused on the retina?
Oh, that's such a hard question. So there are visual indicators that you can use to tell. The most important thing you want to do is you want to make sure that the animal is well dilated. And that seems kind of like a non sequitur because it's a pattern stimulus. You don't want them to be dilated. But the thing is that we're imposing this artificial tiny little aperture. For the mice, it's 1/4 of a millimeter in diameter. For rats, it's 2 millimeters in diameter. So even if your mouse is fully dilated or your rat is fully dilated, we're imposing this artificial pupil on them. So you want to make sure their pupils are as big as possible so that you're lining up right on the middle of that target. In terms of placement, you want to be coming right down the optical axis of the animal. So it's sort of like a 45-degree angle from where they're looking. That's not terribly difficult to do. It's a little tricky at first, but with practice, you get better and better at it. We recently updated our manual, recently as in, I think last week, we updated our manual to include some additional references for and advice on positioning and placement of, among other things, the pattern ERG stimulator. So again, if you shoot an email to support@diagnosysllc.com and just say, I hear you have Rev D of the manual, can I have an updated Celeris manual? I'd be happy to send you one.
Very good. The next question we have relates to the flash stimuli range, specifically in white 6500K, but maybe we can broaden that just a touch and talk about the range we have across a couple of our stimulators, bright, standard, dim.
So we have 3 different stimulators, and each of them have a range of 9 orders of magnitude. And the difference between those is where the center is. So the dim stimulators start at about 10 to the -9th and go up to about like 0.1, 1, something like that. The the brightest ones go up to, help me, Jeff, I forget. The bright ones go up to about 1,000.
They go at least to 1,000 candela seconds.
Yeah.
In white.
Again, in white, and their dimmest is around 0.005. And the standard are sort of in the middle of that. They go up to about 100.
1 log unit lower, yeah, than the bright. So up to about 100.
Yeah, so the range is about 9 orders of magnitude in white, and where the top and the bottom is depends if you've got the dims, the standards, or the brights. And I can give you more precise numbers. I don't have the brochure in front of me.
Those, I think that was a good summary, Natalie. And if someone wants more specific information, definitely check with our sales team or the distributor in your country, and they can give you our Celeris brochure, and you'll have exactly those numbers.
Also, like I said before, you can get a little bit brighter out of using peak than using white. Both of them are red, green, and blue, but white just imposes some restrictions on the color ratios, basically, whereas peak is 1 part green, 1 part red, 1 part blue. So you can get quite a bit brighter in peak than you can in red, than you can in white, excuse me.
And you can also go quite a lot of dimmer by not going in white, but going down in blue.
Oh, you just asked a great question. I like this question.
Well, we've got 1 minute, so this is
Okay.
maybe another topic for another webinar, but you've got
Yeah.
a minute to
There
answer the question.
are incredible pros and cons to both methods of anesthesia. Some gases can actually affect the ERG response. Isoflurane doesn't seem to, but it does knock out the VEP response, as far as I'm aware, because the animals are. I'm not totally clear why. Gas is much easier in terms of animal recovery. It is easier on the animals, so a lot of IACUC committees prefer gas. The ketamine xylazine that's very common can linger in the animals. I know a lot of sites have restrictions on how frequently you can do procedures that take the animals under ketamine. Every 24 hours, every 48 hours, every 72 hours, something like that. No more frequently than that. So if you have to do repeated time scales, sometimes ketamine xylazine isn't quite as good. Another pro to gas is that with ketamine xylazine, it's very difficult sometimes to get the mixture correct. Some animals can just metabolize ketamine like a boss. And also, if you don't use it frequently, it can go off. Aged ketamine can not be very effective. And I've seen some animals take a triple dose that should have killed them and not go down yet. So those are some pros to using gas over ketamine xylazine. Some cons. Sometimes it is impossible to get an animal to get down properly in gas. Also with gas anesthetics, the animals are more prone to take really big gasping breaths, which moves their head against the electrode, which means you see a lot more noise and you can actually see those respirations in the trace. That can be truly exasperating to deal with. And a lot of sites that I know actually wound up switching back from gas back to ketamine because they were like, I'm just done with this. So gas is kind of, there's a little bit of an art to getting the exact mixture of oxygen and isoflurane or whatever gas you're using correct. So it's not the easiest, but they're both certainly good in their own ways. There are definite arguments both for and against both gas and injection. Most common, if I had to make a general decision, standard is ketamine xylazine, and it's kind of the standard for a reason. We do provide a nose cone that's intended to work for or with the Celeris. It's got a sort of magnetic base and its own little mixing chamber that sort of helps with some of the leakage problems. And because one problem is the little sort of fighter pilot mask that a lot of those places come with has the input and the exhaust ports coming out at pretty much the exact angle that our electrodes are coming in at. So we do, if you wanted to use isoflurane, if you've got an isoflurane setup already, that would be a useful argument for it. If you don't already have it, I would say use ketamine and xylazine would be my recommendation.
I'd say probably 90% of the Celeris users use ketamine xylazine, from what I've seen. The vast majority do.
I mean, and some of the ones that don't, like I know the Jackson Lab uses isoflurane, and they do a lot of ERGs, and they have their reasons for doing it. They really like that the mice go in, the mice come out, the mice are awake 10 minutes later. That really helps, especially if you're doing ERGs all day. You don't have to be around to babysit them for a couple of hours as they're coming out of the anesthesia. So it really kind of depends on your flow and what you've got available. But if it were me, I would just be saying.
Excellent. Thank you. Fantastic questions. Thank you for all of the questions. Anna-Rosa, Natalie, any final comments before I close us out?
Thank you so much for coming. I promised everybody a link to download the thing, which I
All right.
have.
Everybody can hold on for a second. Natalie will put that link up, and then we will also have a PDF of the presentation that Natalie and Anna-Rosa gave today that we'll send out within a day, maybe 2 days at the most. And as part of that, we'll have a link to the recording of the session as well. So you can distribute that to colleagues within your institution, or if you're one of our distributors, to customers in your region as well. So we'll have that out within a day or two.
Yeah.
And if you want to try out the exporter software, then just contact the support at diagnosys.com, and we will give you a link to download the software to have a go at it.
Yeah.
Fantastic. And then final point, I think, is we will highly likely have other Celeris webinars, as well as if you're a customer that uses our clinical systems, we'll have webinars related to our clinical systems later this year. We don't have any of those dates yet, but stay tuned. We'll get those out soon. And I think Natalie mentioned this at the outset. If you're a user of Celeris and you'd be interested in speaking with other users and participating in a webinar, let us know. We'd be happy to do that. And we've done a couple of those already, so more the better. Let us know if you'd be interested. That's it.
Sorry.
Yep, go ahead, Natalie.
And again, if there's a topic that you'd like us to address, that you think you'd like us to touch on, feel free to shout it out. We're really finding these to be very useful in connecting with our users and making our equipment more usable for them. So if there's something that you'd like us to help you with, let us know. How to get the recorded webinars, we'll send you an email. Whoever sent you the invite in the first place, we'll send you a link to the presentation that we just gave with the link on the title slide.
Right, exactly. Either through our sales team or the distributor in your country. You can get it from them in, say, two or 3 days.
I got to get it up on YouTube first.
Thank you again, Natalie and Anna-Rosa, for all of your preparation and excellent presentations. Thanks for everyone for joining us, and have a great day or great evening, depending on where you are in the world. Thank you.
All right, thanks.
Bye-bye.